So, okay, good afternoon. So, last lecture we have seen uh, the problem on the design of column by using pattern system, and this I think came to up to the last step, that is design of the connection. So we will see that last step, design of connection. Okay, so bolted connection we will design. We have seen this sum of the part of this bolted connection. So we have to design bolted connection. It means we have to calculate the number of bolts. So number of bolts for this batten system we have to calculate. This number of bolts is equal to longitudinal longitudinal just a minute, spelling mistakes. Longitudinal shear force divided by design strength of the bolt. Design strength of the bolt we have to calculate. So okay, longitudinal shear force already we have calculated. So we have to calculate the design strength of the bolt. So design strength of the bolt, it means we have to calculate strength due to shearing and strength due to bearing. So first, design strength of the bolt in shearing. This part we have seen in the last lecture also, that is VDSB. So how to calculate VDSB? VDSB is equal to N into NB into FUB divided by under root of 3 gamma M1. Okay, so as I told you in the last lecture, the N is the number of shear planes, and for this um, uh, batten system, here N is the 1 only. So 1 into, because number of shear planes are 1. So A and B. A and B is the net area of the bolt. So how to calculate net area of the bolt? 0.78 into pi by 4 into d square. So which diameter we have used? We have used the 16 diameter of bolt, diameter of bolt. So into FUB, 4.6 grade bolt we have assumed. We are using 4.6 grade bolt of 16 diameter. So here 4.6 grade, it means 400 divided by under root of 3 into gamma m1. Gamma m1 is 1.25. So calculate first design strength of bolt in shearing first, then we will calculate bearing, then we will get this number of bolt. How much this? 28 28.97, correct? 28.97 kilonewton. This is the shear strength of bolt in. Then number 2, we have to calculate design strength of bolt in bearing, that is VDPB. So VDPB is equal to 2.5 into KB into D into T into Fu divided by gamma M1. Okay, so here we have to calculate Kb. So Kb. So for the calculation of Kb, we have to first calculate E divided by 3dH. So E, uh, we have to calculate E and P, P's distance and H distance. So 1.5 into dH, and here 2.5 into D. So 1.5 into dH, 16 mm diameter is there. So dH plus how much we have to add? 2. So here 18, and here 2.5 into 16. How much is this?
27.
27 mm and
40 mm.
40 mm. So these are the two edge distance and pitch distance. So now here 27 divided by 3 into 18. So how much this?
0.5.
0.5. So say 0.5. This is 27. And this is 54. Correct. This is 0.5. Then second, P divided by 3dH minus 0.25. So P is 40 divided by 3 into dH is 18 minus 0.25. So how much this?
0.49.
0.49. Okay. Then number 3, we have to calculate what? Fu V divided by Fu. It means 400 divided by 410. It means 0.975, correct? And number 4 is 1. So out of this minimum value, so Kb is equal to how much? 0.49. Are you getting? This is 0.49. Okay. Now calculate VDPB is equal to 2.5 into 0.49 into 0.49 into how much? Uh, into D diameter 16 mm. T thickness. We have to design batten, so we have to take the thickness of batten. What? I think 8 mm. No? How much thickness we have
8
calculated? 8 mm into Fu. Fu is 410 divided by gamma m1 is 1.25. So this is the bearing strength. How much this value?
51.43 kilonewton.
1.43 kilonewton. Okay. So we have calculated the shear strength of bolt and bearing strength of bolt. Now the minimum of these two is the design strength. So which is minimum design strength of the bolt is equal to minimum of VDSB and VDPB. huh, whichever is minimum, this VDPB, sorry, VDSB, how much? 20, 28.97, 28.97 kilonewton. So now we have to calculate number of bolts. So now put the values, number of bolts is equal to longitudinal shear force. How much longitudinal shear force is there? We have calculated. Hmm. VB. How much VB we have calculated? हाँ कौन सा मुश्किल का हेलो कौन सा बोलिल का 98 पॉइंट समथिंग काय तर आपण कॅल्क्युलेट केला VB लॉन्जिट्युडनल शिअर फोर्स काय झालंय कोणच बोलत नाहीये VB ची व्हॅल्यू आपण कॅल्क्युलेट केली ना लॉन्जिट्युडनल शिअर ओके 93.86 किती वेळ लावला आहे सांगायला 93.86 divided by this value 28.92 how much number of bolts 3.23 it means uh, we have to use 4 number bolts correct we have to use 4 number of bolts okay so these number of bolts we have to require for connect batten and column but for that we have to take check so we have to take check so how to check we have to take check it means whatever number of bolts we have calculated that are safe or the resultant force we have to calculate so how to take check so we have to take resultant force so the formula is we have written in the procedure resultant force in extreme bolt resultant force in extreme bolt is equal to the formula is given force in each bolt due to shear square plus force due to movement in extreme bolt square it should be less than design strength of bolt okay so how to calculate now this each field force in each bolt we have to calculate first force in each bolt due to shear is equal to. So we have given the formula how to calculate force in each bolt. Force in each bolt due to shear, it means actually this is longitudinal shear. Here write down longitudinal shear is equal to, how to calculate, VB divided by N. So VB divided by N. N is the number of bolts. So VB 93.86
6.
93.86 divided by how many bolts are used? We have 4. So calculate force in each bolt. एका बोल्ट मध्ये फोर्स किती येईल? टोटल लोड लॉन्जिट्युडिनल फोर्स किती होतोय? 93.86. तर नंबर ऑफ बोल्ट्स आहेत 4 आले, तर एका बोल्ट मध्ये किती येईल? तर फोर्स इन ईच बोल्ट ड्यू टू शियर, दॅट लॉन्जिट्युडिनल शियर. 93.86 by 4.
23.47 kilonewton.
23.47 kilonewton is the force coming in the each bolt. Okay, then we have to calculate movement due to, sorry, force due to movement. Movement मुळे किती force येऊ शकतो? Because movement is already coming. We have calculated movement arising due to horizontal force. So due to this movement, how much load coming in the bolt? So here we have to write force due to movement in extreme bolt. That how to calculate this? M into P divided by summation of P square. This formula we have to use, and for that we have to calculate this pitch. We have to calculate. So see, actually there are total 4 bolts are there. This is column and this is batten is there. This is column. So here total 1, 2, 3. 3 pitch are there because 4 bolts are there. So 3 pitch are there. Are you getting? In this way. So 3 pitch are there. So pitch distance we have calculated. How much? 40. So movement into pitch, that distance we have to. How much movement we have calculated?
13.14 kilonewton meter.
13.12 into
4.
10 raised to 14 into 10 raised to 6 into here pitch. So how much pitch distance is there?
40 mm.
40. Divided by summation of pitch. So here how many pitch are there? 1, 2, 3. 4 bolts are there, so that's why 3 pitch are there. So summation of P, it means 3 into 40, correct? Summation of P, 1, 2, 3, 3 into 40. So calculate this. कीजिए तो है. इथं चुकतंय का? How much this? Summation of p square they have written, no? So it means we have to square of this value. 36.5. Correct?
36.5 kilometer.
Okay, correct. Swapnil has given answer. Correct. Okay. Okay. Now we have to put these values. So we have to calculate the resultant force in extreme bolt. So resultant force in extreme bolt is equal to resultant force in extreme bolt is equal to under root of 27.47, 23 point, how much? 23.47, 23.47 square minus or plus 36.5 square. Calculate this. 43.39.
39.
So actually this value should be less than design strength of bolt. Actually it should, hence this is not safe. Are you getting? याच्यापेक्षा कमी नाही आहे व्हॅल्यू. Now one note we have written in the procedure. Please read. Everyone has written in the procedure. At the last one note is we have written, if check for resultant force and bolt design strength is safe, then try more number of bolts up to check should satisfy. नंबर ऑफ बोल्ट वाढवत राहायचं म्हणून सांगितले. आता एक बोल्ट वाढवून बघा. हा, ते कुठं कॅल्क्युलेशन करायला लागणार आहे तुम्हाला? एक बोल्ट वाढवायचं म्हणजे इथे एक बोल्ट वाढवायचा. 4च्या ऐवजी 5 करायचे. ही व्हॅल्यू काय ते बघायची. इथं पण 4च्या ऐवजी 5 केले की काय होणार आहे? इथं 3च्या ऐवजी 4 होणार. फक्त एवढे कॅल्क्युलेशन चेंज होणार. 5 करून हे कॅल्क्युलेशन करा आणि इथं 4 करून हे कॅल्क्युलेशन करा आणि परत ह्या व्हॅल्यू कॅल्क्युलेट करा आणि परत इथं पुट करायच्या. डू फॉर 5. जोपर्यंत चेक सॅटिस्फाय होत नाही तोपर्यंत नंबर ऑफ बोल्ट्स वी हॅव टू इनक्रीज. Okay, now here write increase one number of bolt, then resultant force is equal to काय होते बघा. तो पहिला फोर्स number 1 force in each bolt is equal to VB by 4. So VB is 93.86 divided by 4 or 5 sorry. How much this? नोट काय लिहिलेली आपण बघितली का? जर हे सॅटिस्फाय नाही झालं तर काय करायचं आहे, जोपर्यंत सॅटिस्फाय होत नाही तोपर्यंत काय करत राहायचंय, नंबर ऑफ बोल्ट वाढवत राहायचे फक्त. नंबर ऑफ बोल्ट वाढवायचे म्हणजे काय करायला लागतंय, इथं जिथं 4 आलं तिथं 5 करायचे. हा, फोर्स ड्यू टू मुवमेंट इथं पण याच्यातली कॅल्क्युलेशन चेंज करायचे आणि परत करत राहायचं. फोर्स ड्यू टू मुवमेंट. Okay, now force due to movement. Now here m into p divided by summation p square. It means 13.12, oh sorry, 13.14 into 10 raised 6 into 40 divided by here number of pitch. कारण 4 number of bolt वाढले की pitch वाढणार. So 40 square. How much this true distance? Tell me. Tell me answers. किती वेळ लागतोय?
18.77 kilometer.
18.77. And this
20.53.
20.53.
20.53.
Now resultant force किती येतोय, is equal to under root of 18.77 plus 20.53 square. How much this?
$27.82.
27.82. It should be less than design strength. Design strength किती आहे?
28.97.
28.97 kilonewton. It means now safe. Okay, hence safe. Correct. So in this way we have to design the baton system. Everyone got this? Okay, so this is bolted connection. So we will welded connection. We will see the welded connection also, because welded connection is so fast than the bolted connection here in this case. So we will see welded connection also. This procedure everyone got. जर चेक सॅटिस्फाय नाही झाला तर एक बोल्ट इन्क्रीज करायचा, परत कॅल्क्युलेशन करायचे, जोपर्यंत चेक सॅटिस्फाय होत नाही तोपर्यंत बोल्ट इन्क्रीज करायचा. म्हणजे आता या प्रॉब्लेम मध्ये किती बोल्ट्स आपण प्रोव्हाइड करणार? ऍक्च्युली बाय कॅल्क्युलेशन 4 आलते, बरोबर आहे, तर आपण ते 5 केले. 5 केल्यानंतर आपला चेक सॅटिस्फाय होतोय. सो यू हॅव टू प्रोव्हाइड 5 बोल्ट्स. ओके, सो नाव हियर we will use design of welded connection also. Okay, एकाच प्रॉब्लेम मध्ये आपण दोन्ही कनेक्शन बघू. Design of welded connection. So welded connection is so easy. So initially for welded connection we have to calculate the size of weld. We have to take size of weld. So now actually it is again depends upon the कशावरून घेतो साइज ऑफ वेल्ड, थिकनेस ऑफ गसेट प्लेट अगोदर आपण म्हणत होतो, थिकनेस ऑफ गसेट प्लेट. आता इथं थिकनेस आपण काय वापरतोय, बॅटन. सो वी हॅव टू टेक द थिकनेस ऑफ बॅटन हियर. हा, thickness of batten is 8 mm. Okay, so it is less than 10 mm. It means how to take size of weld, on which page this size of weld is given. I think 78. Okay. IS page number, IS code page number 78. Page number 78. So our length of, sorry, thickness of our batten is 8 mm. So size of weld we have to take 3 mm. Why? Because 0 to 10 mm size of weld is 3. 10 to 20 it is 5, like this. 22 then 32 it is 6. So page number 78 this is given. किती size ठेवायचा वेळचा that given on the page number 78, and that depends upon the thickness. Okay, now second we have to calculate throat thickness. Throat thickness T is equal to 0.7 into S. So 0.7 into 3, so 2.1 mm is the throat thickness. That we have seen. Okay, now design strength of the weld is equal to T into LW into what? What is formula? Fu divided by under root of 3 gamma mw, correct?
Yes, sir.
Okay, now here 2.1 into LW into Fu is 410 divided by under root of 3 into gamma mw is 1.24. So calculate the design strength of the weld. How much this?
397.68.
397.68. 397.68 LW. Okay, now we have to take longitudinal shear force coming on the batten. So here by we have to write here, we have to consider by equating longitudinal shear force and design strength of the weld. Design strength of the weld. So longitudinal shear force. If we see, these are the two columns and here we have attached the batten. So we have to weld like this here. Are you getting? So in this way, now we have to longitudinal force. How much longitudinal force is? Now this is VB. Longitudinal force is nothing but VB. So VB is equal to how much? 397.68 LW. Are you getting? So but this VB is the total longitudinal force. So again we have to divide by 2 because we have to calculate the length for one side only. Are you getting, everyone? So this VB longitudinal force is on two channel VB. So if we divide VB by 2, it means we have to calculate the length by one side only. Okay. Now VB is 93.86 by 2 is equal to 397.68 LW. So calculate LW.